Hey everyone, so in this quick video I want to explain to you the difference between threads and processes. So let's start with a thread. What is a thread? I want you to think about a thread as the execution of a program. This is just to give you a picture for your head. A thread has a very more formal definition, but you can think about when you write your program, for example in Java, the program is compiled, processed, and all of that. And then when you want to execute your program, a thread is created, and this thread takes care of executing your code line after line after line. So in a sense, this thread just represents the execution of your program, but there's a more formal definition just for you had the execution of a program. And when we teach concepts in parallel programming where we have multiple threads executing in parallel, we also say a lot of the times the word process. And what we say to students is that a thread is kind of, well, just think about it as the same. Like a thread and a process just are really same things. And the reason for that is that those courses, Introduction to Parallel Programming and all of that stuff, teach on a high abstraction level, and concepts that are taught there really apply to both a thread and a process. And we don't really want to go into the details here, what really is the difference. But here we want to do just a quick dive in what is the difference. So when we really care about, when you really are interested in what is the difference between the two, I want you to remember that a thread is kind of smaller than a process. Well, this doesn't really make any sense right now, but it will. A thread, I saw a definition in a book, is that a thread is kind of a lightweight process, and this is not really a formal definition, and it's just a good idea for you. A thread is kind of a lightweight process. But, well, let's go on. I will show you a picture. This is just a conceptual drawing that I've made for you. This is how you can imagine a process. A process is kind of this big box, and inside of this process there are multiple threads. They really live inside of this process. So the threads, remember, they represent the execution of code, so statement after statement. All those threads have lines of code that are executed inside of the context of this process. So every process defines this execution environment. ENV stands for environment, and execution or an execution context. This is just another word for the same thing. So this process defines this execution context, and what's part of this execution context is, for example, an own view instance of memory. Like, you can think about it as an own view, an own instance. That's not really formal language here, but just you can think about a process having an own concept, an own piece of memory. And when you don't understand what I mean here, really, there's a concept called virtual memory, which is taught in other classes. But while you can imagine that the physical memory on your machine is chopped into multiple pieces, and any process gets a part of it, so it doesn't have to bother about the other parts of memory, and it's part of this execution environment. And this really makes sense, because when you have those threads executing code, like all of those threads executing different code, and you, for example, have an integer array in your memory, like 1, 2, 3, any numbers, then all of those threads can access the same integer array, because they all have the same execution context, they all see the same memory. This is called the shared memory model, which is just really an essential model for all parallel programming concepts. Most of the time we assume this model because we want those threads to work on the same data structures and be able to cooperate on work on this integer array, right? So there are a lot of examples like this. And yeah, this really is the difference between a process and a thread. The process is kind of the defines the execution environment, and the threads are really the executions of codes inside of it. And what's interesting is that those threads can access this memory, obviously, but when we have other processes, like I've done down here, they cannot access memory outside of it. So this is really getting into the details here, but just so you know. So one question remains. Why do we think of them as being equal? Why is this? So when you have, for example, two CPUs, CPU 1 and CPU 2, and let's say this is kind of this is an ugly picture here, but imagine this box just means what the CPU is executing right now. You can think about what happens when two threads are executed, which are in the same process, and then you kind of think about, well, those two threads are executed, and you reason about that. But when you have a process which just has one thread, you can really just kind of cancel the idea of a thread and just think about of a process having code which is executed. So you forget about the part of the execution environment, and you think about the process also just being kind of an execution of a code when it just has one thread. This is completely reasonable, right? And then you can imagine, I execute this process, which just means in a sense that you execute the thread inside of it, but it just has a single thread. So you can also just say, well, you execute this process. And there may be other definitions where every process comes chipped in with one single thread, and that's why we talk about processes being executed. And for example, process 2 and process 3 completely, now my image broke here, completely reasonably are kind of executed on different machines, and you can apply all parallel programming concepts to different processes, but also like to different threads inside of a process. And that's why we kind of refer to them as being similar concepts. This is really, if you want to talk about a process with one given thread inside of it, or if you want to talk about threads inside of a process, this is really, detailed. So if you have not understood all of this, don't worry. This is really, very going into the details here, and this is for the computer systems lecture. Another thing I want to talk about, or just show you, when you think about a process, just think of an application. I just shown you a screenshot from my computer, so this is in German, so Prozessname is really process name. You see those are all processes, and apps like Spotify or Safari or Notability, where I'm recording this right now, those are really processes. So for each app that you're running, your system will create an own process, and this really means makes a lot of sense, because you don't want the information or like the data, the memory stored by Safari being shared with Spotify and vice versa. You want to isolate the two contexts where threads are executing. But another thing I want to show is that per process you have a number of threads right here. So you see Spotify created 42 threads which are able to run Spotify tasks in parallel, and this really kind of maybe gives you a better intuition. Every process is an app, an execution of an app, and defines this context, and in there are 24 threads executing stuff for Spotify. So one thread may be responsible for looking at the new recommended songs, the other one for managing my playlists, I don't know, you name it. So just a small look inside of the really stuff what's happening on my computer, and don't worry about this if you haven't understood, and just remember a thread is kind of a smaller thing than a process. Thank you for your attention.